Hello and welcome back to the lecture on applied econometrics. We have been talking about instrumental variable. In the previous lecture, we talked in detail about the two-stage least square strategy. Now, in this lecture, we are actually going to implement this two-stage least square strategy using Stata. So this is, as I said earlier, is the easiest part of the whole series of this lecture on instrumental variable. It is easier because we have already learned the concept. We have already learned how to interpret the IV regressor and how to actually understand the results. So we will try to actually use the data that we have been using all throughout, and the data is basically national sample survey data. So I already have this data here. I've already loaded this data, and this national sample survey data for Bengal, West Bengal, and I have my do file ready. I also have my Stata output window ready. So we are all set to actually do this work. Now, we know few conditions that we have to keep in mind just to sort of for our own convenience. I'm writing it down. So first thing is that covariance of the error term and the u in the original second stage least square regression, it has to be is equal to 0. And the second condition is that the covariance of z and x has to be high, or has to be significantly good, should be good. Okay, and the third is that the z shouldn't be in regression equation on its own right. Okay, that these three conditions we already know, but we are just going to actually check these three conditions when we are going to implement the code. Okay, let's just do that. Let's first open our do file. Okay, so basically I again will run the wedge regression equation, and what I'm going to do, I'm going to have my log of wedge total as the outcome variable, and then I have my explanatory variable general education experience square 6. And what I'm going to think is that, like Kruger and Angrist in their work, and later on also we found education is not really an exogenous variable, but rather it's an endogenous variable, right? So in this exercise, we are going to actually assume education to be the endogenous variable, education to be the x variable. Okay, so we have to find a z here instead of as an instrument for education. Now, let us first, before we begin, let me actually go back to the code here. So what I have done, I have basically run a simple OLS with log of wedge total as the outcome variable, and education is the endogenous regressor, and these are, let's say, exogenous regressor. We don't have any problem with all these regressors, and we do this regression for the people who are having casual employment, or they're earning wages or salaries. They're not self-employed, and the sector, that's basically the rural sector. So I'll talk about why I have chosen rural sector. So let me first run the regression here. I have run the regression, and let us actually look at the regression result. So I'll go to the output file, and I see that general education, so basically the R squared is 0.4, descent, general education is 0.15 coefficient, so which is significant, and all other variables is significant. If females are earning less than males, basically that all makes sense. Now, what I said is that we are basically going to assume that general education as the endogenous regressor. Let's say from theory we already know that. And then what I'm going to do, I'm going to actually find out the error term from this regression equations. Basically, I will subtract the fitted y from the actual y. So if we do that, so let's say predict wedge total, and this is basically I first predict wedge total y hat, and then I create a variable error, and error is wedge total minus the predicted wedge total. Okay, so I do that. Oh, so actually I've run the regression, so that is why it is actually giving this error. Okay, so I just will run this part. Okay, so already I have this results with me, so that is the reason y, I am basically, I'll show you the result. So basically it is telling 0 changes are made. So we already have the result stored. So let us actually use this result and see if my error term is going to be correlated with the instrument. Now, what is the instrument here? Now, I will bring a little bit of economics here. The instrument I am assuming here is the land ownership, and why I am assuming land ownership could be an instrument. So, let me give you two arguments here. So, land ownership as instrument, okay. So, land ownership, so this instrument, the Z variable is land ownership for education, okay. Now, two possible reasons, two different arguments rather. So, argument one, so if I have land ownership, so think about a rural setting, you don't have a lot of sources of income, but you have land, okay. So now when you have land, you get a sense of security. So you have something to fall back on in your bad time. So when you have a big amount of land, you can afford to send your kid to higher schooling. Okay, so that gives a sense of security, and that helps children from the family to go for higher education. So basically, land ownership is a security, some sort of security, and that actually helps the children to go for higher education, let's say. And when children are getting higher education, that is actually leading to wage, okay, a better wage, better wage. Now the other option is that the land itself could be a source of income, right? So at present, this is a source of income. Now, if land itself is a source of income, that may actually directly contribute to the Y, the wage rate, right? So if I already have my land, and if I, let's say, work in my own land, and if I get some earning from that land, so that is actually going to increase my wages. Let's say I'm working as a wage worker in my own land, okay. So this is another possibility. So in that case, what is going to happen, this land ownership is actually going to be present in the regression equation on its own right. So this is going to happen, okay. So this is something we have to check. We have to check this assumption that we have made. So if the land ownership is actually leading to higher education, so what you have to do, we have to simply run a regression. So the regression for obtaining the relationship between education and land ownership. And the third part is that I have to see if the covariance between this land ownership, let's say land ownership and the error that I've obtained is equal to 0. If these three conditions are satisfying, okay. So basically, again, let me strategize. So first, I'm going to see the correlation between land ownership and error term is equal to 0, if that is satisfying. The second condition, I am trying to check if the correlation between higher education, or I can actually do a regression here, higher education and land ownership is good. And third, I'm going to check if the land ownership is in the wage regression on its own right. Okay, there's three conditions I'm going to check on its own right. So let us do that. So let us go back to the do file. So what I'm going to do, so land ownership I have chosen based on some of my intuitions. And first let me see the correlation between error term and the land ownership. So what is the result, what result we are going to get. So if we do that, correlation between land ownership and the error term, so what I get is this. And also let me run this one also. So basically I'll be done with 2. So I can also run a regress basically instead of regress y on x, and we can also specify that actually if, let's say, this whole condition is there. Actually that's a good thing to do. So let me run again. So this one, I run the first condition, Z and U, correlation, covariance Z and U, and the second condition, I run the first stage least square regression. Okay. So what do we see here? In the first stage, I see that R square is not that great, and the land ownership, the coefficient is also very, very small, but it's significant. Okay. Whereas if I see the correlation between land ownership and error term, this is going to be pretty low, 0.02. So I can consider it to be a very poor correlation. So the first condition is fine. The second condition is somewhat fine because it is not really greatly explaining the R square. So it might be a weak instrument instead of a strong instrument. Okay. Now the third condition, what I'm going to see, the third condition, I'm actually going to run this OLS just to check if, and I'm going to include the land ownership into the regression equation just to see if the land ownership is actually explaining the wage total on its own right. Okay, so let me actually run that and let us actually see the results. The result is here. So we see that actually land ownership is present in the regression equation on its own right. Okay, so it is actually explaining the earnings, wage earnings that we are, people are making in the rural area. Okay. Now, with this, we can at best say that perhaps this IV that I have chosen is not the best IV. Probably it's let's say it's some sort of weak IV. Okay. So with this weak IV, let's still run the regression just to see how the results are looking like. So we know the code by now. So what we do is we write IV regress to SLS, and then the outcome variable log of wage total, and then I have my instrument general education is equal to land ownership, and then I have other list of exogenous variables. Okay, so we can run it. Let's run these. Actually, we can run both of these just to compare, but we already have this results. But let's just run the first one. Let's just run the first one. So the result that we get here is this. So we see that general education, the coefficient has significantly increased, and the reason is, earlier you see the general education coefficient was 0.15, here is 0.23. The reason is when I'm basically using the instrumental variable, it is perhaps the instrumental variable is more relevant in the original regression equation. So it is basically the instrumental variable itself is contributing in its own right. Okay, so that is the reason why general education coefficient has suddenly increased so much, because it is now instrumented with land holding. So perhaps the instrument that you have chosen is not the best instrument, but still we get an idea how to run this instrumental variable regression. Now, going back to the do file, we can also use a command like just ivreg, and we don't have to write to SLS, and we can do the regression, but to SLS itself cannot be the command. Okay, so this is basically the idea of how we can use IV regression using Stata. And you need to, as you could understand, it's very important and it's very critical to actually find out the right instrument to run this IV regression. With this, we end this lecture here. Thank you.